3.7. Okay, look. Diprotic means diproton. Okay? By that they mean, you guys should know by now, di means 2. Okay? So, look. The diprotic. I'm gonna split up the word. 2 protons. The reason they say it like that, they don't mean helium by 2 protons. Look, when you have H, everyone knows the atomic number of H is 1. It only has 1 proton. So I'm gonna draw it here. I'm gonna draw it here. 1 proton and 1 electron. H, the hydrogen ion is what? Doesn't have an electron. It's just H plus. So that's why they call it a proton, because it doesn't have any electrons at all. So by 2 protons, they mean 2 hydrogens. Which one of them have 2 hydrogens? Let's see. This one, the hydrogens aren't part of the acid. Forget the compound itself. If you find the compound you already know, or an element you already know, completely ignore it. Just look at the H's. So you see, I circled every compound we already know. So CH3COO is its own compound. Ignore it. It's an acetate. Carbonate, we already know it. Ignore it. Chlorine, chloride, whatever. We know it already. Leave it. Ignore it. Nitrate, we know what it is. Ignore it. And the sulfate, we know what it is. Ignore it. Which one of these has 2 hydrogens? So here, let's count. This one has 1. This one has 2. This one has 1, 1, and 2. Asking which one has 2. It's gonna be this one and this one. Select the weak acids. This part you have to memorize. This part sadly you have to memorize. But look, okay. So this you can tell it's not an acid. We can completely cancel this one out. This one, because it's used so much, you can kind of, like, when you think of acid, you always think of hydrochloric acid. It's used so much that it's, by now you should know it's strong. Nitric acid, honestly I thought it was weak, but no, it turns out it's strong. So these two are strong. These ones are the weak ones. Acetates, remember, because it has reversible. Same with this one. You know what? You know sulfuric acid is strong, so H2SO4 is strong. Think of this, I don't know, bro, like his little brother or something. He's weak. He's way weaker than the H2SO4. And this one, it's a gas. It's an acidic gas. Which ones dissolve in water to produce a diprotic acid? So that means, for example, SO2 plus H2O. What does it give you? After it dissolves in water, H2SO4. Or SO3, sorry. See, they combine like that. All of these, also, by the way, all of these are basic. Like by nature, remember metal oxides are basic. But these two gases by nature are also acidic. If you put a litmus paper, it's gonna turn them red. So CO2 plus H2O is gonna give you H2CO3, carbonic acid. Also, another way you can tell these are acidic by nature, basic, sorry. The metals are basic by nature, metal oxides. And also, yeah, non-metal oxides are acidic, remember. Strong bases. Again, you kind of have to memorize. Also, this isn't a base. Plus, by the way, this question is so easy because these are the only 2 bases. Only way someone could mess up is they could choose this because it has OH. So you have to remember acetic acid. This is a strong base, this is a strong base. The dissociation. So because it's I forgot the word. Because it only has 1 H, like 1 proton. It only dissociates once. See, that's it. Don't have to write anything else, just what it splits up into. It's like, think of it kind of like this part, kind of like the integral from math. You're trying to get the original. So the original is H plus and NO3 minus, صح? and O3 minus. And what's called? It's good that it tells you in water, so you know what. So you know that it's aqueous. Okay, same thing here. See, you're trying to just get the original, like where it comes from. So it's this one plus the H plus. That's it. Always remember, make sure the charges are correct too. This one, because it's diprotic. Are you looking? It's diprotic. 2 H's. So that means it has 2 H, not just one. So it splits up twice. There's 2 ways you can do this. Here they're asking for you see the 2-step balance reaction. You could do that, but there is also a one-step way in case they ask you. One-step way is 2H plus. So this is neutral. If you take away 2 pluses, what's it gonna be? 2 minus. So then SO4 2 minus. You can remember the charges in 2 ways. Either that SO4 is always 2 minus, you just remember that fact, or if it's 0 and you take away 2, what's it gonna be? 0 minus 2, what's it gonna be? It's gonna be negative 2. So here, look, if you're gonna write the 2-step way, this is how you dissociate. So look, you see here, you got rid of one of the H's and you still have the other one here. Also remember, because look, you know this H plus, you removed 1 plus, you removed positive 1. So this had 0 charge. You removed positive 1, you did minus 1. What are you gonna, 0 minus 1 is gonna be what? Minus 1, the charge is minus 1. And then you have HSO4 minus plus 1, H plus, and SO4 2 minus. So you're like splitting by H's, not by like steps, you're splitting by every H. Also here again, if you have negative 1 and you do minus 1 because you took 1 away, what's it gonna be? Negative 2. Or you could do it like this, look. You have the negative 1. Here is negative 2. If you remove negative 2, what's it gonna be? What's negative 1 minus negative 2? It's positive 1. Here again, it's mainly just memorization. Strong acids. Let me do everything in different colors because it's confusing me too. Strong acids. Strong bases. You have weak acids. You have one weak acid here, and then you have weak bases. No, not blue. Okay, look. Strong acids you have to memorize are H2SO4 and HNO3. Strong bases here are KOH and CaOH2. This is lime water. This is the lime water that's always talked about with CO2. Weak acid, you only have acetic acid, and then ammonia, and down there it was it's carbonate. Here, a way you can remember the carbonates of weak acid, because look, مصح metal carbonate, you have to memorize the equation, where it's like metal carbonate plus acid gives you XXXX, yeah? Whatever. So the way you can remember that this is basic, it reacts with an acid. How else would it react with an acid? If it's acidic, it's not going to react with the acid.